Okay, guys, this is just a quick review demonstration of calculating the mechanical advantage for a bolt. So basically we have this situation where we have a bolt with some threads, and we have a wrench that we would place on the end of the bolt, and then we have basically the circular motion of someone kind of tightening or loosening, whatever you're doing, to the bolt. Okay, so that's what they're saying here when we have ideal mechanical advantage for a bolt with a 6-inch long wrench being applied to the end of the bolt. All right, so I'm going to sketch this out. Always start with that. I'll do a top view because they're going to have a couple of different things we have to look at here. So if I were to look at my top view of this, kind of like this, obviously I'll draw it smaller. I'm not going to draw a hex because that's traditionally the shape of a bolt, but I'm going to just draw it as a circle if you don't mind. Let's just call that our top view of our wrench. I'm going to shade in or just kind of hatch it in. That dark spot is the bolt head. Okay, so there's the top view of our wrench, and then the front view of our wrench would kind of look something like that. Okay, and then of course, kind of coming out the bottom, you would have your threaded shaft. Okay. So we've got some data here. It says it's a 6-inch long radius on our wrench. So from the end of the wrench to the center of rotation, we have 6 inches, right? And then if you look at this diagram here, it's showing the diameter of the bolt. We also have that showing as this is a diameter of a half of an inch, so I'm only interested in the radius. The reason why I'm only interested in the radius is because this is a wheel and axle, so 1/4 of an inch, 0.25. Because let's look at this. The bolt head is the axle, and the wrench is the wheel. Because if I look at this from a top view, remember, I'm rotating my wrench in a circular motion when I'm using it. So in a way, this is a wheel, because that's the motion in which I'm using it. The bolt is also rotating, so that's an axle. Okay? So if you think about it, this top view, you can think of this as a wheel and an axle. So if I look at my equation for IMA, which is distance of effort over distance of resistance, I can immediately realize that my effort is on the wrench. And that's 6 inches. And I can look at my resistance, which is the bolt head, and I know that that's 0.25. All right. So if I want to calculate the IMA of the wheel and axle that's happening on top of the bolt, now I'm not looking at the threads yet. That's a separate simple machine. I'm just looking at the top. Right there I have 6 divided by 1/4, which gives me an IMA of 24. Check my math on that, but I believe that's right. Okay. But there's another simple machine happening here. Because what's happening as I turn that wrench, as I tighten or loosen, there's something happening. The bolt is moving down, or moving up if I'm loosening it, right? The bolt is slowly moving. If you've ever jacked up a car with the jack that comes with the vehicle, you'll notice that it's got a screw, and it's called a screw jack. And as you rotate every one turn of the handle, that jack will go up by only one thread. So every time, if you look at this, this is like a coil, like a spring, wraps all the way around this shaft. Every time this bolt rotates one turn, okay, it lifts one thread. Just one thread for every rotation. Okay? So think about that. That's important to know because in the next image, which I can't do because I printed this off, so I can't like click on the next image, but in your computer, I think there's like a dot, 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 dot down here, and you can click, and it goes to the next image. It'll show this bolt laying on its side. It's expanded, of course, it's zoomed in. And then you can do is you can count how many threads there are laying next to this ruler. I did that prior to doing this video, and I counted 13, can't see that, 13 threads per inch. That's what TPI means. Threads per inch. Okay? So that's good information because if I have 13, I'm going to say TPI, which is threads per inch. If I have 13 TPI on this bolt, I'm going to use that information for my IMA calculation because if I know that IMA equals distance of effort over distance of resistance, let's think about this together. My distance of effort, I'm rotating my wrench. So what is my effort? My effort is this distance, the entire circle distance that this wrench is rotating. So I actually can use 2 pi r, which is the full circumference of the wrench's circle. And I know what r is because it was given to me. It's 6 inches. 2 pi r, in this case it's 6. That's my effort. Because think about it. If I'm tightening a bolt for 1 complete turn, it's going to be the circumference of that turning circle. 1 complete turn. 1 complete turn. That's my effort. And as I just said, if I rotate a bolt 360 degrees, 1 complete turn, it's going to lift 1 thread. This bolt's going to move up or down, depending on which direction I'm rotating the bolt, 1 thread. That distance from here to here. Well, if I counted 13 threads per inch, we can easily just say that the bolt will move 1/13 of an inch. So when I put that much distance in effort, I'm going to get 1/13 of distance movement on the resistance side. So now it's just a matter of plugging that into my calculator. I believe my number down here, 1/13 comes out to 0.07, check my math, 69. My 2 pi r, I gotta punch this in again, but my 2 pi r, I should have prepared a little bit more for the video, but that's when you guys can skip forward, so. All right, so 2 times pi times 6 gives me 37.69. And I'm using a computer calculator, so you guys are probably using pi. Hopefully you are, unless you're using your phone calculators, which I don't recommend, but who's judging, right? So I get 400, and I'm going to round to 490. So my IMA for the threads for each rotation of the wrench is 490, rounded. So this is a pretty massive number, but again, we have an IMA of 24 for the wheel and axle portion, which is the wrench on the diameter of the shaft. But then we also have an IMA of 490 with it lifting 1 thread for every rotation. So now we should put those together because remember, the IMA of every individual simple machine that's working together, when you multiply them all together, will give you the total IMA. So IMA of individual times IMA of the individual of the second one times the IMA. If I had a bicycle and I had, 10 simple machines together in series with each other, I would just keep multiplying them together, and that would give me the IMA total for that complete machine. So I would just do 24 times 490. So 24 times 490 is, oh wow, cool, 11,760. That's my answer. That's the IMA of the bolt with a 13 thread pitch and a 6-inch wrench. That's why you got to be careful when you're tightening things with a wrench. If you put, just a little bit of force, 10 pounds, we'll say, you're squeezing down with 117,000 pounds of squeezing force. That's massive. So that's why we use bolts to clamp things together, and that's our lesson. So hopefully this helps you with Ideal Mechanical Advantage.